Hello, Mr. Harry, Mr. Ryan, are you right? Yeah, not happy, yeah. Okay. Anyway, so today we look at these simple questions. We're given a list of strings and we want to find out the maximum number of pairs. A string can be paired up with its reverse. Okay, so AB can be paired with BA, AC can be paired with CA. So we have two pairs. The ZZ here, ZZ is a very special case. The reverse of ZZ is still ZZ. So what do we call this kind of string? Palindrome, yes. So a palindrome, the reverse of palindrome is still the same. In this case, we are not pairing up with itself, okay? Because look, as I said, okay, the string in this list are unique. So we don't have duplicates here. Since we don't have duplicates, the palindrome cannot pair up with itself because it does not have a duplicate. So given this, maximum number of pairs is 2. We have a couple of solutions to do this. The first thing to do is brute force. Because the question is to find out the number of pairs. Maximum pairs. So when we talk about a pair, so look, these they are n elements, n strings. So n string, if we want to find out the pairs, the total number of pair is Cn2. N element picking 2. 4 elements, 4 apples picking 2. How many ways?
6.
6, okay. 3 apples picking 2, this is 3 ways, right? A, B, C. Picking 2, A, B, A, C, B, C. 4 apples picking 2 is 6. So n apples picking 2 as a pair. A pair is without the orders. For example, AB is the same as BA. So here we talk about the pairs. AB pair up with BA is the same as BA pair up with AB. Okay? So Cn2. So there are total number of Cn2, which is n times n minus 1 divided by 2. And if we find out all the pairs, this is in On square quadratic, because look, we drop the constant here, so it's On square. So if we perform a brute force to find all the pairs, and then we check if these pair, if one of the string is the reverse of the another, right? So then if it is, we increment the counter. Okay, so this is brute force. Define, find pairs, max pairs array. Answer equals 0. N equals the length of A. For I in range N. For J in range I. Then we check if AI is the same as AJ, but reverse, right? We're looking for reverse. Or AI reverse is AJ is the same. Then answer plus equal 1. At the end, return answer. This is brute force. Okay, answer. This is the variable. We are returning this answer. We're counting the number of pairs and store it in answers. Length of A, the total number of strings in N. So I, this is the index of the pair. Okay, so index of the pair, IJ, right? So J is the second index, up to I. So in this case, J index is smaller than I. Okay, so here is smaller. J is smaller than I, means that J and I are not the same. And J is smaller than I. Why do we need a J smaller than I? Here. Why do we need to make sure that the one index is smaller than the other?
So it doesn't look exactly the same.
It's not exactly the same. Look at this, unequal, right? One index is smaller than the other means that so we can get rid of the duplicates. For example, AB to BA is the same as BA to AB. So in this case, AB to BA, consider one pair, but not BA to AB, right? Because J is smaller than I. So I index here goes this way. J index from the first one up to I, right? Up to I. So when I is here, J is here. J is always on the left of I. So we only consider the pair, the pair AB, BA once. Does it make sense? Yeah? So look, AI, the string I, index I is the same as string J, but reverse. We can put this reverse here, right? It's the same. Can we analyze the time complexity here?
N squared.
O(n) squared, yes. Look, it's here. O(n) squared. The pairs, finding the pairs, O(n) squared. The space complexity.
O1.
O1, yeah. So remember, this is On square, O1. This is space. This is time, okay? So, as I said, there are a couple of ways to solve this. Today, we only talk about brute force and then the optimization, which is using the hash set, right? Remember the hash set. What's the data structure set? Hash set.
Set.
Yeah, set. We use the set to store the number of unique. We store the unique elements, right? So we use the set as a data structure to remember the stuff. Remember the stuff. It's a notebook, right? Notebook. So you have a notebook and you see this AB and you put it down, AB. Okay? And the next time you see this BA, right? You see this BA and then you check the BA. What's the reverse of BA? Is AB. And you check if your notebook has AB. You have AB, then you know there's a pair. Am I right? Yes? Yeah? Makes sense. So in this case, we just have to go through the list once, right? From left to the right, right? Makes sense. Look, AB. I'm at AB, okay? I have a notebook. A book, okay? Yeah? A book. This is a notebook. Okay, AB. What's the reverse of AB?
BA.
BA. The notebook is empty, right? The notebook is empty.
Ah.
Yeah, the notebook is empty, so I just can continue. But since the BA is not in the notebook, I put this AB here. So because now AB, I've seen this AB. AC, what's the reverse of AC? CA, okay? And CA is not on the notebook, so I put it here. BA, what's the reverse of BA?
AB.
Is it on the notebook?
Yes.
Yeah, so I plus 1. I have 1 pair. Okay, so then by default, we need to get rid of it. Right? We need to get rid of it. But in this case, because all the strings are unique, so it's okay we leave it, right? But we can delete it. So we have 1 pair. CA, what's the reverse?
AC.
Actually, here we should put the AC, okay? Yeah. CA, what's the reverse? X. It's there, right? So we have 1 pair. Okay, ZZ. It's not there, so we put it here. Make sense?
Yeah.
Okay, so we just go through array once, and then we put down the words we have seen on the notebook. When we are processing the new word, new string, we check its reverse. Okay. By the way, how do we reverse a string? A, B, C, D, E. How do we reverse it? Do you still remember how do we reverse it?
Or
Colon minus 1.
Or 2 pointer.
How do we do this 2 pointer thing?
We go to the first and
Yeah, 2 pointer, yeah.
and then switch and then keep on going towards it until stop it until they meet.
Yeah. This is also a way to check if a string is a palindrome, right? When we check a string if it's a palindrome, we compare from both sides to the middle. Or we swap it. If we want to make, if we want to reverse a string, we do it this way, till middle, okay? We swap. Okay? Also, checking if a string if it's a palindrome, we can reverse it. We can reverse it and then see if the reverse version is the same and it's a palindrome, right? Okay. So coming back to this, let's do the coding for this method, okay?
But what if there's like a million strings? That's gonna take quite a bit to put in the notebook. And you probably need to buy a few notebooks.
Yeah,
to
for
put a
notebook.
million.
Yeah, that's the space uses. Think about the space uses, okay? Answer equals 0. Then scene table equals a hash set. We use a set. So for I in array, we go through we process each word in the list. Then we check if the reverse version, colon minus, is in scene. If we seen it before, answer plus equal 1, and then we need to remove it, right? Scene.remove. Remove I, colon minus 1. Otherwise, we edit scene.add I and return answer. Okay? What's the time complexity here? Look.
ON.
ON. Okay. What's the space complexity?
ON.
ON. Okay. Actually, technically it's not ON. It's ON times M. M is the length of the string. Okay. Length of each word, each string. Okay. So let's assume the length of each string is 2. Okay. Only 2 characters. It's only 2 character. 2 character lowercase string. Okay, let's add a requirement which is 2 character, size of 2 character, and then all lowercase. Okay, with that in mind, we can talk about the optimization in the next lesson because there are two more solutions we can talk about. Okay. Today we talk about two solutions. First one is the brute force. The second one using the hash set. So look, this approach here is on space on time. The first approach is on square time one constant space. So which one is better? Which one is better? What do you mean on? Which one is better? First one or second one? Which one?
Second one, because brute force is so bad.
Okay, that's a very good point. Okay, when I talk about which one is better, I mean, my question is not complete, right? Better in terms of what? We have to compare something against something in terms of what, right? When I say better in terms of what?
Better in terms of how good it is.
So better what? Of speed or the much of the space uses? So look, the first brute force is on square. The second approach using the hash set is on, the time. In terms of time, obviously the second one is faster, right? On is faster than on square, right? Remember the graph. On here, this is on square. Yeah? Okay, but space usage, which one is better? In terms of space, which one is better?
Brute force.
Brute force, because it's all one constant. It only uses constant space. But the second approach using the hash set, right? Hash set. Okay. So there's one thing I missed.
Completely.
Yeah. There's one thing I missed is that the removing. Okay. So why do we remove here? If we don't removing, for example, like if there's duplication, like AB,
There could be several. There could be like an odd number of the same one.
That's right. Yes. AB, BB.
And they'll just count that as one.
Yeah. If we don't, very good point. Look, if we allow duplication, then here, right? If we have a pair, right? We have a pair. Well, maybe here. Right? We already pair up here, and if we're not removing this, then this will pair up at another time. That's why we need to remove it. But to simplify, we don't allow duplication, so it's fine. We keep it or we don't keep it. That makes sense, yes? Okay. So if we allow the duplication, then that's this algorithm may not work, right? Because you see this AB, and then BA, and then this algorithm will fail to detect its two pairs. But actually the results will be two pairs. But using these, it will only tell you it's one pair after removal. Okay. Yeah? Make sense?
Yeah.
For the brute force, if the duplication for the brute force, it doesn't work. Did I mention that a string can only be paired up at most once? Right? It cannot be paired up twice. For example, like AB can pair up BA, and AB, if there's another BA here, it cannot pair up. Okay? It can only be paired up once. Okay?
Yeah.
Okay. That's it for today. Bye bye. Bye bye.